Hi, this is Mr. Marino again. If you see here, all I did, this is the same, it's continuing from the last video for the intro. So all I did was cross out intro, cross out past 7. This is only for past 6, chapter 2.1, and we're talking about matter. This is a very difficult chapter because you've probably never seen a lot of these words before, and the book kind of thinks you have. So, I want to explain a mineral a little bit more. Mineral, it says that the definition in the book on page 43 says it has to form in nature, so nature creates it. 2, it has to be a solid. So it means like something hard, not a liquid, not a gas. But the next 2 are kind of difficult. It has to have a definite chemical makeup, and it has to have a crystal structure. What does that mean? Well, if you look back at our periodic table, the study of these things is called chemistry. So having a definite chemical makeup, what that means is that we know what it is made out of. Which one of these elements makes that one? For example, if I have the crystal diamond, right? I'm sure everybody knows what a diamond is. Diamond is made of only of one element, only carbon. Carbon squished together under very, very strong forces makes diamond. But all it is carbon. But it is made in a crystal. And that is the 4th definition. It says it has to have a crystal structure. So that is the main thing I want to talk about in this video. What is a crystal structure? Well, a crystal structure, if you think about, atoms are very, very tiny. You can think of them like this thin. Let me change the camera so I know that I'm focused. You can think of them as thin as a piece of paper. Actually, in this thin piece of paper, there are probably millions of atoms. So thin. But these atoms, if you look at this picture, it's mostly space. Even between these. When this connects with another atom, it's mostly space. But if you think about most things like this, you cannot see through it, right? Even though it's mostly space there, you cannot see through it. Why? Well, here's one sheet, but the next sheet could be arranged like this. So if you see, it blocked out some of the holes, right? Then this one can be arranged like this. I blocked out, you can only see me a little bit. The next one is arranged like this. So if I do this millions and millions of times, eventually it's solid, like the book. You cannot see through it because you cannot see through the holes. What is a crystal? A crystal is when they are all together in a perfect pattern so that you can see through it. And if you think about it, think about crystals like diamond, like rubies, like, what's another crystal? Like topaz, like emerald. All of those crystals have something in common. It means one of the things it has in common is that you can see through them. And why can you see through them? Well, they're arranged perfectly so that you can see through it. And the more perfect the structure, the more you can see through it. That's why if you can really see through it, it means it's a very perfect structure, and sometimes it can be a very expensive crystal. Another thing that was in this chapter were elements, which you should watch the introduction to this chapter so that you know what an element is. But if you didn't, not me looking at myself, this is an element. These are all the different elements. There are 118 of them. You need to know maybe like 5 or 6 of them for this class. And you already know oxygen, nitrogen. You'll learn a few more. If you look on page 47, it talked about different crystal groups. What does that mean? That only means how these that are perfectly in order, here I just made a flat square, right? But it doesn't have to be a square. It can be a perfect, like a hexagon, and just hexagons on top of hexagons together that can see each other. It can be a few different shapes, but the most common, I don't want to say the most common, but one of the most common shapes is it just looks like a square. It's cubic. It's just, imagine this piece of paper again, but in a cube. It's just stacked, so inside, if I zoom in, these atoms just make a square. So let me draw a crystal if I zoom in. Say I'm going to do a crystal of hydrogen, just because it's easy to draw. Hydrogen cannot really make a crystal. That's not important right now. And we're sharing this minus. As you can see, they start linking up like this, right? So this is a perfect square. And if this was another perfect square up here, 4 and 4, it'll make a box like this, right? And that's why it's cubic shape. It doesn't have to make a cube. This is a cube. A hexagon crystal, for example, would look something like this. I'm not good at drawing hexagons. Hold on. There we go. Hexagon, finally. So imagine there's an atom here. We don't know how big. There's an atom here, atom here, atom here, atom here, atom here. And I keep putting hexagons on top of each other. Like imagine this was a hexagon instead of a rectangle. Hexagons on top of each other. They'll make a crystal that is hexagon. So that is what page 47 is talking about. And these minerals can make those kinds of hexagons. Bye.